Hello and welcome back to the third and final lesson of chapter 1. We are in the first two lessons of chapter 1. We looked at the two different types of variables. We had categorical variables and we have quantitative variables. Categorical variables are values that fall into different categories. Quantitative variables are numerical variables where it makes sense to find the mean of the data. We were taking those different types of variables and different data sets and we were organizing them in some sort of graph or distribution, whether we looked at a bar graph or a pie chart or a dot plot or a histogram, and we were describing those different types of distributions or graphs. Today, in our final lesson, section 1.3, we're going to be describing quantitative data with numbers as opposed to just observations. So remember, when we were looking at distributions, we described a distribution using the acronym CUS or SOX, depending on which you prefer. CUS is center, unusual features, shape and spread, or SOX is shape, outliers, center, and spread. When we were describing each of these characteristics of a distribution, we were just estimating them based off what our eyes saw. So we would estimate the center, estimate the spread, the shape, and the unusual features. Okay, so they're all just what we saw with our eyes. Today, we're going to put numerical values to each of these characteristics. We'll start with the center. One way to measure the center is the mean. Another word for mean is the average. The symbol for the mean is X bar. It's an X with a bar over it. And that means it's the mean of the sample. To find the mean, you're going to add all the observations together and divide by the number of observations that you have. Another way you might see it is we're using a sigma. The Greek letter sigma means sum. So it's the sum of all of the observations divided by the number of observations that you have. This is how you find the mean. This is one way of measuring the center of a distribution. Another way to measure the center of a distribution is to use what's called the median. The median is the midpoint of the distribution, where half of the observations are to the left and half of the observations are to the right. To find the median, you're going to arrange all of the observations from smallest to largest, or largest to smallest, whatever floats your boat. Then, if the number of observations that you have is odd, the median will be the center observation. If the number of observations that you have is even, the median is the average of the two center observations, because you won't have one single center observation. Okay. Here is an example. This is the data of the commuting times in minutes of 20 randomly selected New Yorkers. We're gonna show the difference between the mean and the median. So at the mean, we're gonna take these 20 New York commute times and we're gonna add them all up and divide by 20. So the average X bar, the average commute time for these 20 randomly selected workers was 31.25 minutes. To find the median, we're going to take all of these data points, put them in order from smallest to largest. In this case, we're going to use a stem and leaf plot. And then we're going to find the median. Because there are 20 observations, the median will be the average of the two center observations, which are 20 and 25. So the median is 22.5 minutes. Notice that the average and the median are not the same. And that's okay. They're not always going to be the same. But that means it's going to be tricky when describing the center, because you could choose one or the other. However, there is a correct and incorrect choice when looking at a data set. And we'll talk more about that in a few minutes. So again, we have two options for measuring center, the mean and the median. And we're going to have to choose, based off of our data, which one we're going to use as the center. So those are our two options. After the center, we have to find a way to describe the spread. Okay, the spread, we also have two options. The first option is called the interquartile range, also known as the IQR. Okay, so measuring the center can be a little misleading. So we also want to figure out how spread out our data is. To calculate the interquartile range, or the IQR, you have to calculate the quartiles. The quartiles break the data up into 4 quarters, where 25% of my data lies within each quarter. Okay? To find the quartiles, you're going to arrange the observations in increasing order and locate the median. The first quartile is the median of the first half of the observations. Okay, so again, the first quartile is the median of the observations located to the left of the median. So it's the median of the first half of the data. It's called Q1, first quartile. Quartile 3 is the median of the second half of the data. That's called Q3. The interquartile range is when you take Q3 and subtract Q1. So it is the difference between Q3 and Q1. So here we are with the 20 New Yorkers and their travel time. I want to find the IQR. Okay, so I'm going to take all of these data points and I'm going to put them in order from least to greatest. And then I'm going to find the median. The median, we said, is the 22.5, because it's in between 20 and 25. Q1 is the median of the first half of the data, which is 15. Q3 is the median of the second half of the data, which is 42.5. So you have Q1 and Q3. The interquartile range is when you subtract those two values. So 42.5 minus 15 equals 27.5. The interpretation of that in context is the range of the middle half of travel times for the New Yorkers in the sample is 27.5 minutes. Okay, because that tells you 50% of my data lies within 27.5 minutes of each other. Because Q1 to Q3 is 50% of my data, right? If these broke up into quartiles, Q1 to the median is 25%. Median to Q3 is 25%. So that means Q1 to Q3 is 50%. It's half my data. Okay? The larger the IQR, the larger the spread. The smaller the IQR, the smaller the spread. So IQR is one way to numerically describe the spread of a data set. When we are identifying outliers, we can use the IQR. So last section, we were looking at data points and we were kind of just saying, oh, this might be an outlier, or this kind of looks like an outlier, but we had no way of knowing for sure if it was an outlier. Now we do. Okay? We can do a rule called the 1.5 times the IQR, and this is a rule to help us find outliers. What we can do is we can take the IQR, which in our case is 27.5, and we can multiply it by 1.5. When we do that, we get 41.25. We take that value and we add it to Q3 and subtract it from Q1. Anything more extreme than Q3 plus 1.5 times the IQR, or Q1 minus 1.5 times IQR, anything more extreme than that is considered an outlier. Okay, so when you take 41.25 and subtract it from Q1, you get negative 26.25. We do not have any values less than negative 26.25. So there are no outliers to the left. However, when you take it 41.25 and add it to Q3, you get 83.75. Any value bigger than 83.75 is considered an outlier. In this case, we have one value bigger than 83.75, so we have confirmed that we have one outlier. 85 looked like an outlier, and now we have confirmed it numerically that it is, in fact, an outlier. Okay, which brings us to our 5-number summary. Okay, so we are describing data numerically. We've already found 3 of the 5 values. Q1, the median, and Q3 are 3 of the 5 in the 5-number summary. The other 2 values are the minimum and maximum values. Okay, so a 5-number summary of a distribution consists of the smallest observation, the minimum, the first quartile, Q1, the median, the third quartile, Q3, and then the largest observation, the maximum, written in order from smallest to largest. That is a 5-number summary. Okay. A box and whisker plot takes this 5-number summary and puts it into a picture. Okay, so we call it a box and whisker plot. So to make a box plot, you want to draw a box to represent Q1 to Q3, a line that marks the median in between Q1 and Q3, and then lines called whiskers that extend out to the smallest and largest observations. You will then mark the outliers with some sort of symbol, usually a dot or a star. So if we have outliers, our whiskers do not reach the outliers. They go to the smallest and largest observations that are not outliers. Okay, so let's look at an example. So again, here's our New York data. We put it from least to greatest. We have our Q1, we have our Q3, we have our median. Okay, to make a box and whisker plot, we're going to draw an axis like you see, and it's given a title, travel time. We're going to find the median, find Q1, find Q3, see the minimum, and then see the max, but just don't forget, the maximum value that we have is an outlier, and we found this by using the 1.5 times the IQR rule. Now a box and whisker plot is going to take Q1 and put it here. This is Q1. Q3 is the end of the box, and the median is a line in the middle. So the box is Q1 to Q3, also known as the interquartile range. So a box and whisker plot shows the interquartile range, or the spread. Then you put your whiskers. They go to the min, and they go to the max, and then you put a dot where you see your outlier. This is a box and whisker plot. It gives you a visual of your 5-number summary and your outliers. Okay? Don't forget, we can do this on our calculator. So right now, pause the video, go grab your TI-84 calculator, and in our last lesson, we looked at this data set on a histogram. We looked at the 20 female AP Stat students, and we asked them how many pairs of shoes do they have. Okay, so like last time, I already have my data in my calculator. For those of you that forget how to input data into your calculator, you hit Stat, and you go to Edit, and then I have the data right here. If you don't have the data, you're going to pause this video and rewind it a little bit to go look at the data and input it into list 1. Once you have it into list 1, we're going to go ahead and we're going to quit, which is the blue button above mode. So you hit seconds, mode, and now we're back to our home screen. Okay, we're going to make a box and whisker plot, and that is in our stat plots, just like our histogram was, because that's where all of our statistical analysis plots are. So we hit seconds, y equals, which brings us to our stat plots. I'm going to go into my first plot, plot 1, and I'm going to make sure it is turned on. Okay, now when I'm looking at type, if you look at type, it looks like there are two box and whisker plots in your calculator. And that is because there are. One's a box and whisker plot, and one's called a modified box plot. Now, a modified box plot is the box plot that we use because a modified box plot will show outliers. In our previous example, we looked at a modified box plot because we put a dot where the outlier was. If you chose this box plot that's highlighted on my screen, it would not show outliers. It would have the whisker go all the way to the outlier and you wouldn't be able to see it. So we're going to choose the modified box plot, and that's the one you're going to choose all the time. And you're going to hit enter. And when you do, it'll ask you, where is your data? Again, my data is in list 1, so I'm going to leave L1 there. But if your data is somewhere else, then you might want to change this to wherever your data is at. Frequency is 1, and then the mark is just the mark that you would use where there is an outlier. So you can choose whatever mark you would like. Okay? And then you hit graph. Okay? Here is my box and whisker plot. If you don't like the window, you can always hit zoom and then go down to zoom stat, which is number 9. Oh, number 9. Okay? And that fits it a little better. Okay? As you can see, there doesn't seem to be any outliers in my data because there's no dots on my screen. If I wanted to actually find the 5-number summary, I can hit trace, and you will see there is the median. I go over, there is Q1. I go over, there is the minimum. I can go back to the right, and there is Q3. I can go all the way over, and there is the maximum. Okay? The box that you see is the interquartile range. So Q3 is 36, Q1 is 17. The interquartile range is 36 minus 17, which in this case is 19. Okay? And the median is 25. The median is not always directly in between Q1 and Q3. Right? As you can see, the median is a little closer to Q1 than it is to Q3. Okay? And that is how you do a box and whisker plot on your calculator. Okay. There is another option for measuring spread. It's called the standard deviation. And this is the most common measure of spread. And it looks at how far each observation is from the mean. Okay? So consider the following data on the number of pets owned by a group of 9 children. Aw, this just reminds me of my dog. Here is the number of pets owned by 9 children in a dot plot. Okay, so this person, 9 pets, they own a zoo, or this person has 1 pet, it's probably a dog. We are going to first calculate the mean, because we got the standard deviation is how far away you are from the mean. So we have to calculate the mean first. Then we want to calculate each deviation away from the mean. Okay, deviation is just the observed value minus the mean. All right. So our mean here is x bar, which is 5. The average number of pets owned by these 9 children is 5. So the deviation from this point right here to the mean is -4, right? 1 minus 5 is -4. The deviation from this point here is +3, because 8 minus 5 is 3. And we would do that for every single data point, which in this case, it's only 9 data points, so we could technically do it. And we have the deviation of each data point to the mean. If you add all these values up, what do you get? Yeah, you get 0. Okay? So adding these values up is not useful, because when you add all the values up, you should get 0, because you should have some values above and some values below. That's how you find the mean. So instead of looking at just the deviation, we're going to square the deviations. So now everything is positive. So now we're looking at deviation squared. Okay? Now, when you add all these values up, you get an actual number, okay? This is not the standard deviation. This is called the variance. So you take the sum of the deviations squared, add them up, and you divide by n minus 1, okay? Technically, it's called degrees of freedom, but we'll look at that later. So n minus 1, you're dividing by the degrees of freedom. So 52, which is the sum of the deviations squared, divided by 8 is 6.5. That's called the variance. And then when you take the square root of that, you get the standard deviation, which is 2.55. You are essentially finding the average deviation from each point to the mean. Okay, so that is how you do it by hand. Obviously, there's a way to do this on the calculator. In fact, you can do this all on the calculator. Okay? Let me show you. So here we are on our calculators again. We're going to clear the mode. We're going to quit, so we're on a blank screen. And again, right now in my data, I have that same list of data from the number of shoes owned by the 20 female students in AP Stat. Now, if I go to Stat, you'll see it, that we've been going into Edit. But let's go over to Calc. So go over to Calculate, and you'll see 1 var stats. If you hit Enter, it will ask you what list you want me to take the stats of. And the answer is whatever list your data is in. So my list is list 1. I'm going to leave the frequency list blank, and then I'm going to hit Calculate. And when I do, it gives me everything that I could ask for. It gives me X bar, which is the mean. This symbol here, S sub X, this is standard deviation. So I don't have to calculate it by hand. N is the number of observations. I have 20 female AP Stat students. That's why N is 20. If you go down, you'll start seeing your 5-number summary. Here's the minimum. Here's Q1. Here's the median. Here's Q3. Here's the max. And these are the exact same values that we saw when we made a box and whisker plot on our calculator. So it gives you the 5-number summary, it gives you standard deviation, and it gives you the mean in 1 var stats. So no, you don't have to do this by hand, but you should understand where it comes from. Okay, and this is the symbol that, the formula that is for standard deviation. So here's variance, and then here's standard deviation. As you know, the first thing we did was we found variance, and variance is just the square of standard deviation. So standard deviation is S sub X. If you were to square it, you would get variance. Okay, now these symbols and formulas, you get them on a formula sheet. They're not super useful because you never have to do this by hand, but you should understand where they come from. Okay, this formula is just saying you're going to find the difference of all of the deviations of all the points, square it, add them all together, and then divide by what's called the degrees of freedom, which is n minus 1. Okay, and then our last thing is take the square root of it because the inside is just variance, and we want to find standard deviation. Okay. Now, I've given you options, right? I said, hey, you have 2 options to define the center and 2 options to define the spread. But how do you know which one to choose? Well, they come in pairs, okay? If you were to describe the center of a distribution using the mean, then you would describe the spread of a distribution using the standard deviation. If you were to describe the center of a distribution using the median, then you would describe the spread of a distribution using the interquartile range. You don't mix and match them. They come in pairs. Now, when do you choose each pair? Great question. The median and IQR are better when there is some skewness or outliers in the distribution. Let's talk about why. Skewness and outliers move the center of the distribution. And well, they move the mean, sorry. They move the mean. Let's just think about if I had a neighborhood of 10 houses and 9 of the houses were worth $1,000 and one house was worth $10 million. The $10 million house is an outlier. The median price of the house in that neighborhood is still just $1,000. Okay, that's the middle number. However, the average, the mean, is much higher than $1,000 because of the one outlier. So it doesn't represent the actual center. So if there is some skewness or outliers, you are to choose the median and IQR to describe the center in the spread. If a distribution looks reasonably symmetric, roughly symmetric, and there's no outliers, you would use the mean and standard deviation to describe the distribution. Okay, to describe the center and the spread. Okay, so again, if it's skewed, you use median and IQR, and if it is roughly symmetric, you use mean and standard deviation. Okay. Numerical summaries do not fully describe the shape of a distribution. Always plot your data. Okay. So you might think, oh, I'm going to find the median and the mean, and if they're the same, then I can just use either one because there would be no skewness. No, you want to make sure that you plot your data and look at it visually. Okay. We are in the process of doing a full data analysis, and part of it is finding the numerical summaries, and part of it is looking at the distributions. When we put those two together, we're going to get closer and closer to a real image of what's happening with the data. Okay. Ultimately, we're in this year, we want to organize a statistical solution, right? So we want to be able to answer questions using data to back us up. Okay. When we are solving more complex problems, we are going to follow what's called a 4-step process. And the first is to state. So we're going to state the question that we're trying to answer. Okay. Then we're going to plan how we're going to go about answering the question. What type of techniques are we going to use? How are we going to gather data? Are we going to use inference testing? Then once we plan, we're going to do all the things that we plan on doing. We're going to make graphs. We're going to carry out calculations. We're going to actually collect the data. And then we're going to make a conclusion based off of the data that we have collected. Now, everything that we do needs to be in context. So the conclusion needs to be in the setting of the real world problem. And you should never have an answer without context. So the mean should have context. So if we're talking about fish and the average is 7, it should be 7 fish. Okay, if we're talking about dogs, it should be 8 dogs. Standard deviation, there should be a unit for that. So we had, if we were talking about minutes traveled in New York City, then it should be 2.55 minutes, because we should be talking about minutes traveled. Everything we do should be in context of the problem. So ultimately, this is the 4 steps that go into doing a full statistical analysis. And we are at the very beginning of analyzing data. And we're going to ultimately, by March, we'll put it all together and be able to do a full data analysis. I hope you guys learned something, and I will see you all in the next chapter, chapter 2.